Hello, my name is Robert Reeder. I am a contributor to Passagemaker magazine. Today we're talking about bathymetric navigation, which is navigation using the contours of the bottom of the ocean to determine our vessel's position in the absence of GPS or in addition to it. This is the first of two different methods of bathymetric navigation we will be discussing. It is called the line of sounding method, and it is the method that was discussed in the April 2017 issue of Passagemaker magazine. To begin with, I have prepared my chart for this navigation. I have my dead reckoning laid out from a previous dead reckoning track. This is my 0600 dead reckoning. I've laid this out in 3-minute intervals because that's going to make my math easier. Normally, I would be in 6-minute intervals because that's 1/10 of an hour and that makes the math easier. But for the work we're doing here, a 3-minute interval made the most sense to me. I want to point out that this is a technique that really does require a committed navigator. You cannot be steering the boat and doing this at the same time. This is one of the virtues of GPS navigation, is that when GPS and chart plotters came into being, it took away the need for one crew member. Without GPS, we need to bring that crew member back. So this is the job of the navigator. This is not the job of the person who is helming the vessel. Also, I want to point out this chart, we are operating in water that is close to land and close to good aids to navigation. In the real world, we would not use this technique this close to land. We would use the land masses unless it was very foggy. It just happened that this chart had good bottom contour for this demonstration, and so we're using that. But this would be a more offshore technique in most circumstances, or else in very dense fog. So my first technique is called a line of sounding. In both of these cases, I'm going to use a rectangle of tracing paper or tissue paper or something like that. This happens to be tracing paper. I draw a line in the middle and I start my line of soundings with my 0600 DR. Now, this presumes that I have some basic understanding idea of where my vessel is. I'm not just dropped out into the middle of the ocean and starting from scratch. So this is my 0600 dead reckoning position, and I assume that I am somewhere within a mile or so of this. This is my 0600 position. My course is 120 degrees true at a speed of 10 knots. So in real life, I would be using the fathometer and I would be watching the fathometer as it goes over my contours. In this case, my contours are marked in 10 fathom increments. So every 10 fathom unit, I would be writing down the time of that crossing. And also I have to consider my tides, where my transducer is, how far down below the waterline my transducer is, and calculating for that. In this case, I am simply assuming that the actual 10 fathom units are when I'm actually crossing that line. So I have canned data here. This is the same data that was in the April issue, if you're following along with that. And I'm going to use the same canned data for two different types of bathymetric fix. So we'll see how, using two very different techniques, how we derive hopefully the same answer. So this is 2 minutes and 30 seconds after I begin my run. So I'm going to go into my time, speed, and distance wheel. I know that I'm doing 10.0 knots. I went 2.5 minutes. So 2.5 minutes at 10 knots is 0.42 nautical miles, which I take off of my latitude scale. Now, for all of our navigation, we want to use our latitude scale for mileage, not the longitude scale. Our latitude scale, 1 minute of latitude is 1 nautical mile. Our longitude scale is going to be different depending on how far we are away from the equator. So we're always going to use this as our mileage scale. So 0.42 nautical miles, which I've just picked off of here. And I'm going to go onto my piece of tracing paper that I made. And from time 0600, I'm going to make a tick mark and label that 30 fathoms. And then I'm going to wait again until my next 10 fathom sounding increment. My next one is at time 06430 is I'm going over my 40 fathom curve. So my distance from 0600 is, I'm going to not go through the time, speed, and distance calculations for each one of these because I already did it, is 0.75 nautical miles. Notice that I'm going back to my time 0600 DR, not my most recent. If I have a small error, I don't want that to be cumulative. And so I'm anchoring my times back to the beginning of my run rather than adding on to the last one. That's kind of a personal preference, but it has worked for me for a long time. So 0.75 nautical miles is there. Again, going back to my time 06. Make a tick mark, and that is 40 fathoms. So we continue watching our depth sounder from our time 060430, our 40 fathom curve. Our soundings continue getting deeper. We get down to 50 fathoms at time 060930, which is 1.6 nautical miles from the start of my run at time 6, or 0600. So I again pick 1.60 nautical miles. Again, going back to the beginning of my run. Mark that as 50 fathoms. Now, if I look on my chart at this point, I've seen that I've gone from somewhere around 22 fathoms at the beginning of my run, and I came over the 30 fathom curve, which is what I expected, came over the 40 fathom curve, which is what I expected. I did not really anticipate going over the 50 fathom curve. I thought that I would skirt to the north of that, so I am apparently not exactly where I thought I was, which is why we're getting a fix to update our dead reckoning. But this is where I can start getting a visual sort of mental idea of where I might actually be as opposed to where I wanted to be. So my soundings continue getting deeper from the 50 fathoms, but they never reach 60, and they start coming back up again, and I cross my 50 fathom curve on the way back up again at time 0611, at which time I have gone 1.85 nautical miles from the beginning of my run. And I make my tick mark for my second 50 fathom curve. Again, coming back up, coming back shallow, which is not exactly what I anticipated, but it's what I'm seeing. At time 6:16:30, we cross back up over the 40 fathom curve. 2.75 nautical miles from the beginning of my run. And again, with this method, I'm doing all my work on my tracing paper right now. I wouldn't even need to have the chart under it necessarily. It just happens to be on the table. I crossed the 30 fathom curve at time 0618, 30 fathom curve, which is 3.05 nautical miles from the beginning of my run. Okay, so I have my line of soundings on my tissue paper, on my tracing paper. And now I'm going to line that up with my dead reckoning. And immediately when I line it up with my DR, I see that my soundings do not line up at all with my dead reckoning track. So now I need to adjust my tissue paper, my tracing paper, to meet with what reality was given to me by the depth sounder. So in this case, I immediately see I have this 30 fathom hill that I did not go over. So that is going to steer me in this way away from that dead reckoning. And my first sounding was 30 fathoms, and so my 30 fathom curve is here. I'm going to start lining up from that. There we go. So this is my time 0600 where I actually was. This is where I crossed 30 fathoms. 40 fathoms, 50 fathoms. Note I didn't actually go over this little hill here, or this little dip rather. Cross 50 fathoms again on the way back up, 40 fathoms and 30 fathoms. So this is the only place in this area where my line of soundings lines up with my actual charted soundings. So at this time 30, I'm going to take my divider point, poke through. It's okay to tear that. I won't use it again. And my fix, my bathymetric fix at time 0618 is right here. I'm using a triangle as the symbol for my bathymetric fix in the same way that I use a triangle for my radar fix. And the reason for this is that in the case of radar and bathymetrics, I'm using electronic equipment, but I'm getting the data from the real world around me as opposed to a mathematical abstraction as with GPS. So it's not a true electronic fix, it's not a true visual fix, it's a hybrid in between, so the triangle is the classical symbol that we use for that. So I have plotted the fix, I have labeled the fix at time 0618, and then I am going to lay my DR. I've already drawn it in, but I'm going to go to my compass rose, and I'm on a course of 120. So from my crosshairs to the 120 is here with my parallel rulers. And then I bring my parallel ruler down to my fix. Draw my new DR track. I continue with my 3-minute fix interval. This is time 0618, 0621, 0624, 0627, 0630. So that is the line of sounding method of bathymetric navigation. Our next installment will be a different method of bathymetric navigation using this same data done a different way. Keep watching and have a good watch.